Assalamualaikum, myself Ahmad Khan, roll number 21T76, and I am performing digital signal processing lab number 9, which name is FIR filter using window method. So in this lab, our first task is to use example 7.4 and plot the filter in the time domain along its magnitude response. So for that we go to MATLAB, and here you can see that by using the example in which filter coefficients are given for these filter coefficients are given to us, and then we by using Hamming window formula length h w Hamming into and hw is equal to h dot w, and then we plot impulse response by in the discrete form for to into plot discrete signal we use temp, and legend we use hn and wn, and X label, Y label, title of the is impulse response with and without Hamming. Similarly, for the numbers to be in the lines for 0 to 1000, we use line space frequency, and these are the frequency vectors, and we are plotting now the magnitude response for which we are asked about in the question. So we have given the frequency at W and figure. Now we subplot the ABS is for the abstract H value and at W value, and like this way you do subplotting in the first of all in the magnitude response and then in the phase response. So when we run this program, so when we run this program, here you can see that first of all we get a magnitude response with and without Hamming signal, and red blue line represent H of H, and red line represent W of F. Similarly for phase response it is of. So we got two graphs for which we have to do the plotting, and it is the impulse response with and without, as which we plot in the starting timing window. So this is the first task, and now we are moving towards the second task. Sorry, this is the second part of the first task, in which you we have to use window with filters and observe the magnitude response and discuss the window magnitude response. So note is given that the users are n is equal to 5 of 12. So similarly, we take the frequency coefficients as in the earlier program. Then we have taken the length as given in the question that n is equal to 512 line space for data to be in the arrangement range form, and then we plotting for this we use the for loop, because we have to plot three, we have to work in three windows. For that we use a for loop, and then we plot the given signal like window we have given that Hamming, Henning and Blackman. Window 1 length h as given in the earlier frequency coefficients, absolute value frequency hw1 f1. Then we do the plotting and legends, and legends are for that to mention the in the graph that these are belong to these, and x label, y label is for the x-axis and y-axis, and title is for the whole graph. When we run this, as you can see that blue line belong to Hamming, red line belong to Henning, and yellow line belong to Blackman. So this is the response by using three windows with filters. Now we will move towards the second task, in which we have to given the signal, and we have to plot its time and frequency domain and implement any example from 7.5 to 17.10 for given signal. So I plotted 7.5 example. So the data is already signal generation data is given to us at f of s t x1 x2 t and x1 and x. So we have to design FIR filter design. For this we take carrier frequency, which is in example 7.5, fc is equal to 800, n is equal to 3, and use the formula by for applying filter we use FIRL, and then we use this formula of the filters and then transfer function and difference equation. In the example we have to also plot them, so for that we use transfer function to system to difference equation and display, and is it like that. We use magnitude frequency response which we have given example, and then we do all plotting of all of them, and when we run this program, as you can see that we have input signal frequency domain of input signal and magnitude frequency response which we give command to plot. Now we will move towards our task number 3, in which we for first we have to use noise reduction. We have to implement a example in section number 3, section 7.4. So this is the example which we have to give, that we in which length is given, frequency is given into f of s, and ax key is given to us for the audio signal. Like in the starting, we have to sample frequency, then subplotting of the signal number of samples, and then length is given to us, and like that for audio signal in which sample frequency are important, and number of samples which are important we are given to us, and we implement them according to our formula and apply formula for the digital cutoff frequency and attack. And when we run this program, here you can see that there are a number of samples, and these are graph is for frequency. So, and it is for number of samples and frequency. One is for ASK and other is for WNC. And now we will do our last task, in which task 3 second part, in which we have to audio read this as speed signal for the audio read signal we use for the any music audio. We have to implement on MATLAB. We use the audio read signal, and then speech for speech portion we have given it like one from 250, and now we subplot the frequency number of samples original speech signal as which is in it, and now with the number of samples, for that we use the formula of frequency 0 1 by 2 fs by n a, like in the previous we program we use. So we implement them like here, and when we run this program, here you can see that it is for original speech signal, and then magnitude spectrum of original signal, and after magnitude spectrum filtering. After filtering, the magnitude spectrum is selected, as you can see clearly here. So moving towards last portion, in which as in the earlier program we implement speech. Now in this program we will implement music file and then run this program similar, but in this case we use two software which is tutor and woofer. Tutor is for low pass filter and high pass filter for tutor frequencies, and low pass filter is for woofer frequencies. So we the changing is that for music we use for high frequencies we use tutor, and for low frequencies we use woofer, and then we run this program. And when we run this, here you can see that original music signal, high pass filtering tutor, and low pass filtering woofer. So you can clearly see the difference, that when I filter pass, this is a signal, and when low pass filter apply, this is a signal. This is all for lab number 9. Thank you.